Welcome to the Data Hall YouTube channel. In this video, we are going to talk about correlations. So how do we interpret correlations? How do we interpret them if we have a dummy variable or a categorical variable? What is Pearson correlation or Spearman correlation? How do we execute them or run them in Stata? What do we mean by listwise or casewise deletion or pairwise deletion? And a bunch of different concepts that are related to correlation. So starting with data, let me import this data. We are using this UCLA data. So this data have scores of students from high school. There are around 200 cases, 200 individuals, and let me show you the data. We have ID, the gender, race, the social, the social status of the student. Then we have the type of the school, the program, and then scores for different subjects, for example, read, write, maths, and science, and then we have this score for social studies, right? And let's run correlation for this data, and let me show you how do we do this correlation from menu. So we click on statistics, then summarize table, and then again the first option, and down here we have correlation and covariances. Let me first do it using the menu, and then I would give you a quick overview of the code that it would generate. So we select the variables. So this time let's select gender, and then show social status, and all these scores that we have. Instead of clicking OK, I would click on submit, and this would keep this dialog box open. Now we have these correlation values, and this value of 1 is the correlation between the variable itself, which would always be a positive, perfect positive correlation, and it would have a value of 1, but it is nothing that we need to interpret. What we are interested in is so what a correlation would tell us. It would tell us the association between two variables. So what is the association between, say, gender and the score on reading, right? Or what is the association between a score on science subject and how well a person can do score in math subject. So it tells us association between two variables. So in correlation, there is a misconception. Some scholars would call them independent and dependent variables, but in correlation we do not have any dependent variable, neither independent variables, and that's why when you see the dialog box of the correlation, you would just see variables. Let me show you the dialog box of linear regression, right? The simple regression. You would see a dialog box for a dependent variable and independent variables. So that means in regression we do have dependent and independent variables, but in correlation we do not have independent or dependent variables. These are just variables. So it doesn't mean that there is a positive correlation between say, for example, science and math score. So it doesn't mean that if someone would score higher marks on science subject, that person would also score higher in math subject. Or we cannot say that a person scoring higher marks in maths would also score higher in science. It doesn't show causality. So we do not know the direction of the impact from correlation per se. It is just that how these two variables move together. So would science and math score would move together? We know there is a strong correlation. Now, so it tells us association, and there are two aspects of the association that it would tell us. One is the direction. So is there a positive association between the variables? If one moves forward, the other would also move forward. If one moves backward, the other would also move backward. So they move together. The positive correlation would mean that these two variables move together, and a negative correlation would mean that they would move in opposite directions. So for example, there is a negative correlation between, say, the gender and maths, but we would come back to the categorical variable in a while. Let's first understand the continuous variables. These scores are continuous, and these two variables are categorical. And having these categorical variables, these two categorical variables, they are for a reason in this table, and we would discuss them. Okay, it shows us the direction. We have discussed the direction aspect and also the strength of the association. Is it a weak correlation? Is it a moderate correlation or a strong correlation? The higher the value is the absolute value. The higher the value is, the higher is the stronger is the correlation. So, there isn't a specific values, but normally what we would say is anything between 0 and 3. I mean, these are absolute values: 0 and -3 and 0 and +3. These are weak correlations. Then value between 3 and 5, 0.3 and 0.5 are modest correlation, and anything above 0.5 is considered a strong correlation. So these all values, you see these 0.5, 59, 66, these are all considered strong correlation, whereas this one, the relationship between social studies score and science score, is considered a moderate correlation. Whereas this value, because it is between 0 and 0.3, it can be negative or positive. We are concerned about the absolute values. This is a weak correlation. Now we do not normally have any specific chart for this or specific values, but if you are interested in having to reference something, then there is a reference for you, which is Davis 1971 parameters. So it have categorized these correlation values between these categories. So anything between 0.01 and 0.09 would be considered negligible. Anything between 0.7 and 0.99 would be considered very high. But normally we do not report these Davis parameters in our papers. We just categorize them into weak, strong, and moderate correlations. Okay, so how do we interpret these correlation between the categorical variable and, let's say, continuous variable? Let's take this value. What would this negative sign mean? I mean, this female is a dummy variable, and to understand dummy variable, let me show this to you in the data view. You would see that a value of 0 is assigned to male and a value of 1 is assigned to female. So we would interpret this with respect to the value 1, right? So this means that females have lesser score or reading score as compared to males. If this gender variable had a value of 1, then we would this gender variable, male variable, would had a value of 1, then we would say that this negative sign would represent that male have slightly less reading score as compared to female. So in categorical variable, we would interpret it with respect to the category that is assigned a value of 1. If that is a dummy variable, dummy variable have a value of 0 or 1. In case of this social status, we have 3 categories, and we can see that over here we have low, middle, and high. And if I wanted to show you the categories, then we can use codebook command and try the variable name. It shows that a numeric value of 1 is assigned to low category, 2 to middle, and 3 to high. So what this this positive correlation between social science this social status and all these scores means that as the social status increases, the scores on these subjects would increase, and the highest impact seemed to be of the status on the social studies score. So this is how you interpret these values, but it gets tricky when you do not have any levels. So for example, this race variable do not have any level, and it do not have any, it isn't a dummy variable, so there are not just 2 categories. So interpreting this would become a difficult task with correlation table. You can have different dummy variables for different races, and then you can input them in your correlation, or you can use other techniques that we might discuss in our other videos. Okay, so this brings us to the current correlation that we are using is currently we are discussing Pearson correlation, and the correlate command is use the Pearson correlation method, and this Pearson method is normally used with the continuous variable. So this brings us to the topic of listwise or casewise deletion. Listwise and casewise are synonyms. So what listwise deletion means is that if they are if there are missing values, then while calculating these correlation, the Stata would remove all those cases. So that's why it is called case-wise deletion. So let me just let me show it to you how many number of observations this correlation command have used, and we can get that number of observation using return list command. And we know that the previous command that we used of correlation is using 200 observations to calculate these values, and that is because we do not have any missing values. Let's generate few missing values here and there, and let's see what this would do. Okay, that's enough. Let's rerun this correlation command. The values are different from the one we had previously, and let's see how many observations this Stata have used. There are 193 observations, but why is that so? Why do we have 193 observations? If we see that most of the variables have 200 observations, but what Stata is doing is with this correlate command is it is removing all the students or all the cases. It isn't considering them in calculation of this correlation that have any missing value. So if we would open this data, we would know that this case 1, 2, 3, 4, 5, 6, 7. So these 7 cases, these 7 students are those that had any of these values missing. So while calculating correlation, Stata would not take those cases. It would delete those cases. It would remove those cases from the estimation of correlation. And these have certain repercussions. One is that obviously case-wise deletion would reduce the sample size, and it might also introduce certain biases in the analysis. Say for example, it would be only biased, the analysis would only be biased towards the students who are sharing their scores, and normally the students who scored lesser would be reluctant to share their data, their scores. And so these correlation, these analysis with case-wise deletion might be biased, skewed towards the students who are sharing the data. And for that we would have another option which is called pairwise deletion. And what pairwise deletion would do is, let's say it is calculating the correlation between read and write, and there are only two missing values between in both these variables. It would only remove these two cases rather than removing the 7 cases which are missing in a whole data. So it would just remove the cases, the pairs, the pair of where the pair have a missing value. Okay, so let me execute this this pairwise correlation. For that, we click on Statistics, Summary Tables, and the same first menu, but now we click on Pairwise Correlation, and the command would be PWCORR, right? CORR stands for correlation, whereas PW would stand for pairwise. We would select the variables, and let's select the same variables in the same order. Okay, and last one is this. Click on Submit, and we do not know how many number of observations it took, but let me click on this option which says print number of observations for each entry. And now we know that for calculation of this specific correlation, the correlation between the gender and the social status, it had taken 200 observations because there was no missing value. But for each of the correlation value, there are different number of observations based on the missing values that a specific pair had. So the command for correlation was CORR, and then we write the variable name. For pairwise correlation, it is same. We just use the pairwise correlation command, PWCORR. And if we wanted to have number of observations, then we would use the OBS option. We can do the same listwise deletion with this command if we check this box which says use listwise deletion to handle missing values. So it would become exactly same as the exactly same values as we had with the correlate command. So if I show you the values, with the correlate command we had 0.6092, and we would have why is that so? Okay, so this wasn't 6.6077. So this is the exact same value that we would get using the correlate command. So we can use this option, which would be exactly the same as the correlate command. We can also print the significance level. So with let me remove these listwise deletion and observations, number of observations, so that we can have clean table. So now we would have a significance values, and anything below point or equal to 0.05 would mean that the correlation is significant. And with this, I would like to discuss the difference between the statistical significance and substantive significance. So these are the two terms that we must understand. So a correlation would be substantive significant when the R is either moderate or strong. So any value that is correlation value that is greater than 0.3 would be called substantive significant, right? But it might or might not be statistically significant. The statistically significant would come from the p-value. So any value being less than or equal to 0.05 p-value would be statistically significant. We would be confident on our result. We would know that the population correlation is not equal to 0. But it doesn't mean that that correlation is substantive. So we can see here, although the correlation is significant, the p-value is less than 0.05, but it is statistically significant, but it is not substantively significant because the correlation between these two variables is quite weak. And one more thing is that this statistical significance would might come from the higher number of observations. So the higher the observations are, the more likely it is to have a statistical significance, even if the correlation is not substantively significant. Okay. Instead of, let's just say, these p-values, let's say we wanted to have these statics, then we can select this option and we can let the Stata know at what level we would want to have asterisks. Any correlation value that is significant at 5% level or lower levels would have asterisk values. If I use 1%, then you would see that we would okay, these are all okay, so we wouldn't get a static value with the correlation of female and signs. So that correlation the static sign is removed. What this option would do is it would remove the values that are not significant. It wouldn't show the values that are not significant at that specific level of significance. And if we wanted to use the code, then for observations we would use OBS. For listwise deletion, we would use listwise. For having p-values, we would use SIG, which stands for significance. To have asterisks, we would use star and the level of significance, and to get only the significant values, we would use the print command. And lastly, if we are interested just in these individual values, individual correlations, right, then that's fine. But if we are interested in these correlation as a whole, which we aren't in this case, but let's say we are, then we would have to adjust these correlation values using some adjustment. In the menus, we have them over here. We can either use Bones-Frohney method or Sizak method for the adjustment of the significance values. So it won't change the correlation value, but it would just change the significance level. It would adjust the significance values. If you are interested in just the individual correlations, then you do not need to adjust for these. Mostly we are interested in individual correlations. Okay, next we move to Spearman correlation, and this what Spearman correlation do is that it would first rank the so why do we need Spearman correlation? We need them for ordinal data, or if data is not normal, there are, say for example, influential cases in our data, then those influential cases would skew the correlation value to one end. And what Spearman correlation would do, it would use ranks rather than the original continuous values of that variable. So let me have the auto data. I use the sysuse command, and let me use the clear option because we already have the data in the memory. So we have 74 observations. We have our data set, and let me remove these unnecessary variables so we can clearly see what we want to do. Okay, price and weight. I'm just interested in price and weight. And what Spearman correlation would do is it would create a variable and rank it. So not creating a variable, but rather use the ranks of the variables to generate correlation. So let's say I create a variable using egen command. Let's call this new variable rPrice, and let's rank it on price. So we have these ranks. Let me first sort it on price. So you'd see that lower price would get a lower rank, whereas the higher price would get a higher rank values. Similarly, we would have ranks for the weight variable. Okay. And let's now do simply correlation between price and weight. And let me show you that correlation. The correlation value is 0.53, and this correlation is higher because the prices are somewhat skewed. Let's say they have influential cases, they are not normal, or they are ordinal data. And for that, let's run the correlation between the rank variable. We see that it is the value is lesser than the correlation value if we had used the original variables. Now we are using the rank variables. So what Spearman would do is that it would give us the exact same value that we had with the rank variable. So I just wanted to demonstrate what Spearman is doing. It is creating the rank. We do not need to perform all these steps. We just use Spearman, price, and weight, the variable names, and it would create a rank of those variables and give us the correlation value between them. The interpretation would be same. So there is a moderate correlation between price and weight, but the methodology behind the calculation of Spearman correlation is different from that of the Pearson correlation. I hope that was fruitful, and I hope that you have learned something from this video. Thanks for watching it.